Hello grade 10s, welcome to today's lesson. Today we're going to be going over literal equations, inequalities, and that's linear inequalities, as well as word problems. So we're going to be dealing a lot with the logic, and you're going to have to think during this lesson. Make sure that you have pen and paper and you're taking notes and your brain is fresh and ready for it. Let's begin with some literal equations. Now, you'll see on the board it says we're doing literal equations, changing the subject of the formula. Next, linear equations and word problems. Literal equations are when we have a group of letters in an equation. Now, sometimes there will be numbers as well, but generally it's just letters. And they will ask you to solve in terms of other letters for a particular variable, not letters, variables. So let's say we're going to solve for m. So the question says solve for m, and then it's got y is equals to mx plus c. And you know from previous experience that y is equals to mx plus c is, of course, our straight line formula. If they want us to solve for m, it means they want us to rearrange this formula so that m is the subject of the formula. We're going to start by moving c over. Now the way we move c is we actually minus c from both sides, because plus c minus c gives us nothing. And that means we're left with nothing on the right, which is what we want, and we've got y minus c on the left. Now we're solving for m, so it means we need to get rid of x next. X is multiplying m, and that means when we get rid of it, we divide both sides by x, giving us y minus c divided by x is equals to m. Now this doesn't look very attractive, so we're just going to rearrange it so that it looks like m is equals to y minus c divided by x. Literal equations are when we just apply your linear equations and your quadratic equation rules to a group of variables, and we solve for that variable as it is. Let's move on to linear equations, or linear inequalities. Now, linear inequalities is when we have an inequality sign. For instance, this is if it was x is less than or equal to 2. And this would be x is just less than 2. Whereas over here, x would be greater than 2, and x would be greater than or equal to 2. Now all of these we can represent on a number line. The number line is a basic line with the important number listed on it. So in all of these cases it's going to be the number 2. Then you would draw a circle above the 2 to indicate it is the important number. If the inequality sign includes an equal sign, so for instance this first one is x is less than or equal to 2, then we color in the circle, and this means it is included. 2 is included in the list of values that x can be. Now x is also less than 2, so we put the arrow going down, and there is our number line. For the next one, 2 is the important value. Again, we have the arrows on either side to indicate the line goes on forever and ever. This time, however, 2 is not included, so we keep the circle open. With the next one, 2 is the important number, but it is not included, so we keep the circle over, and x is greater than 2, meaning the values of x are above 2. And lastly, when x is greater than or equal to 2, 2 is the important number, the circle is colored in, and the arrow goes above. Now, linear inequalities are pretty much exactly the same as linear equations. You treat them in exactly the same way when you're moving things from one side to the other. The only difference is when you multiply or divide by a negative number. So you multiply or divide both sides by a negative number, the sign will change direction. And that's the only thing that's different. Let's try one quickly where that happens. So we'll create some space. And let's have negative x plus 7 is less than or equal to 5. First thing we're going to do is get rid of the 7. It is adding, so it means we're going to minus it from both sides. And that means it's going to be 5 minus 7. Now, because we've just minus 7, the sign does not change direction. It's only when we multiply or divide by a negative number that it changes direction. So now we have negative x is less than or equal to negative 2. How do we get rid of that negative? Well, we're going to multiply both sides of the inequality by a negative number. And that, of course, means that the sign swaps around. Another way to think of it, if you're uncomfortable with that, is to move x to the other side and to move 2 to the other side so that the sign stays the same direction, but x is being minused on the one side, so it's added on this side, and 2 is being minused, so it's added on this side, which is actually exactly the same as that over there. So you don't have to remember any funny rules. The other curveball that they can throw you is that they'll have 3 parts to the inequality. So you'll end up with an answer of 2 is less than or equal to x, which is less than or equal to 5. Now they're going to start this with quite a complicated looking problem. Let's look at one and see how we handle it. Okay, so let's start with the question. 2 is less than or equal to 2x minus 3, which is less than 4. Now we need to solve for x. So that's what we're going to have left in the middle at the end. What that means then is that we need to start by moving the negative 3. Now usually in an equation, a normal equation, we would add 3 to all the sides. And we do that in a linear inequality as well. So we add 3 to 2, we add 3 to the middle terms, and we add 3 to the 4, and we get an answer of 5 is less than or equal to 2x, and of course the 3 has disappeared because we added 3 to it, which is less than 7. How do we get rid of the 2 now? Well, the 2 is multiplying the x, so that means we divide all the sides by 2, and we're now left with 2.5 is less than or equal to x, which is less than or equal to 3.5. Oh, sorry, which is just less than 3.5. The way we would illustrate this on a number line is you would plot your important numbers, 2.5, 3.5, and x is between them. And of course the dot above 2.5 is colored in because there is a line underneath the inequality indicating that x can be 2.5 as well. We're now going to work and move on to methods that we can use for solving word problems. Now these are recommended methods that I have found that have worked through the years. However, you might find methods that work for you that are different to what you have. There are 3 set problems that I have methods for, and then the other problems we just have to kind of figure out as we go along. But don't worry, we're in this together. Let's take a look. Okay, the first method I'd like to go through is our length and area. So if you have a length and area problem, you are going to need to use simultaneous equations. And that means you will have a value for x and a value for y. Now, it doesn't mean that you'll always use simultaneous equations. Sometimes you are able to just use x and you don't need to solve for y as well. For money problems, I use a table. So anything that involves buying things, buying a total of things, problems, buying a total number of things, I use the table with these three values: T, E, and N, where T is the total price or the total cost, E is the price of each, and N is the number of items. And what this triangle allows us to do, there's our T, there's our E, and there's our N. What the triangle allows us to do is to see the formula to work out each of those. So in other words, total is equals to each times number. Each times number. Total is equals to each times number. Each is equals to total divided by number. And number is then, of course, equals to total divided by each. So if you want to find out the number of items that are purchased, you take the total cost and divide it by the number of items. Now there's a very similar method for speed, distance, and time. And these are our two most common problems: speed, distance, and time, and the money problems. Speed, distance, and time, some of you may have already come across this, where speed is equals to distance over time. So if you want to find your speed, you put your distance over your time. And if you want to find your time, your distance divided by your speed. And if you want to find your distance, you multiply your speed and your time together. Those are the three basic methods that we use for word problems. However, we don't always have word problems that fit into those. So the main thing is to be flexible. If you are wanting to be good at word problems, it's going to require a lot of practice and a lot of thought into other areas. It's worthwhile getting to know how to solve them because they're more applicable to everyday life than other things in mathematics. Let's move on to some literal equation examples. Okay, the first question says solve for I. So what I'm going to do is make I a different color quickly. Just makes it easier for me to see what needs to be solved for. So if P is equals to V times I, and I've got to get I alone, it means I need to move V. What is V doing to I? It's multiplying, which means when I move it to the other side, it now divides. Now just to make it look nice, I'm going to swap it around so that I is equals to P divided by V. Or at least I is equals to P divided by V. Let's move on to the next one. Make M the subject of the formula in E is equals to MC squared. Highlight the M so that it's easier to see. Now I need to get rid of the C squared. What is the C squared doing to E? Well, it's multiplying. So how do I get rid of it? I'm going to divide both sides by C squared, giving me E divided by C squared is equals to M, which of course means M is equals to E divided by C squared. Now that one was quite easy. So let's change it slightly. I'm going to give you a new question. Make C the subject of the formula. Now this will be more difficult because c is actually squared, and we don't want c squared as an answer, we want c. The original formula was E is equals to mc squared, and we just want the c. So what's the first thing we're going to do? Well, we're going to get rid of the m, and the way we get rid of the m is dividing both sides by m, leaving us with E divided by m is equals to c squared. How do I get rid of the squared? I'm going to square root both sides, leaving me with the square root of E over m is equals to c. Just to rewrite it nicely, c is equals to the square root of E over m. Let's move on. C. We need to solve for t. It's not too difficult. There it is. And let's rearrange things. Now I'm going to start by moving the u. So it's v minus u is equals to at. How do I get rid of the a? Well, it's multiplying on this side. So I'm going to divide both sides by a and make it equal to t. And we've solved for that. I'm just going to rewrite it neatly. T is equals to v minus u divided by a. And the last one is definitely the most difficult. Now, whenever you're faced with fractions in your literal equations, the first thing you need to do is find a lowest common denominator. And remember, with your other equations, if you find a lowest common denominator in an equation, you are able to get rid of the denominator, and that's what we want to do in this case. So we're going to look for a common denominator, and then we're going to remove the common denominator. Let's start. We have three different variables over here, a u, a v, and an f. So that means our lowest common denominator is going to be all three of them and multiplied together. So that means I am going to have vf over vuf as my first term. My second term, I just need to multiply by uf, which means I have uf over vuf. And on the other side, it's f. I need to multiply by uv over vuf, and there's my new equation. Now I'm going to put this left-hand side all over one denominator, just so that it looks more pretty. Over vuf, and it's equals to uv. How do I get rid of the denominator on both sides? I'm going to multiply by the same number on both sides, which just happens to be the same value as the denominator. Of course, you don't have to show these calculations, but I'm doing it for your benefit. And now we have vf plus uf is equals to uv. The original equation, or the original question, asked us to solve for f, but what we find now is we've got two f's and they're not like terms because of the u and the v that's attached to them. So how are we going to get them apart? This is the only difficult part of literal equations, so if you can remember this trick, you're going to get it right every time. Let's see what we have to do. So we've got vf plus uf, which cannot be added because of the v and the u. However, you are lucky enough to know how to take out a common factor. So if we take out a common factor of f, we're left with v plus u, and the f has been removed. That's equals to uv. Well, now that the f is separate and the brackets are multiplying the f, we can then move it to the other side by dividing both sides by the brackets. That means that f is equals to uv divided by v plus u. And that really is as difficult as literal equations get. If you can do linear equations and quadratic equations, you will be fine in literal equations. They're nice and easy, they're good marks to have. Let's move on to some questions on inequalities. Okay, linear inequalities. The first one has a fraction in, and remember I've said that inequalities are very similar to equations. So if there is a fraction, then we might as well find a lowest common denominator and put everything over the same fraction, which is going to be 6. And then we're able to get rid of the 6. Now remember, the only reason the sign will change direction is if we multiply and divide, or divide, by a negative number on both sides. We don't need to change the left-hand side at all because of the 6 that's there already. But the right-hand side, in order to put it over a common denominator of 6, we're going to have to multiply the top and the bottom by 6. Now that we've done that, we're able to get rid of the denominators on both sides by multiplying both sides by 6. And that means we can cancel the denominators, and we are now left with 4x minus 2 is greater than, and let's multiply this out at the same time. 6 times 2x gives us 12x, and 6 times 1 gives us 6. Now that we've done that, we can solve for x, and I'm going to bring the x's over to the left and all of the numbers to the right. 4x stays where it is, but the 12x needs to be with it. So it now becomes 4x minus 12x is greater than 6 plus 2, which leaves me with minus 8x is greater than 8. But now we have a problem. What is the problem? Well, the only thing I said that was different about inequalities was if we had to multiply or divide both sides by a negative number, which in this case we do have to. We've got negative 8 times by x. We need to get rid of the negative 8 by dividing both sides by a negative 8, meaning that our sign will change direction because we have changed the signs on both sides. 8 divided by negative 8 is going to be negative 1. So that means x is less than negative 1. If we were to illustrate this on a number line, negative 1 would be your important number, it would be an open circle, and x would be less than it. Let's move on to the next question. The next question has two fractions in, 1 over 2 and 1 over 3, meaning we're going to have to find the lowest common denominator again. Well, 2 and 3, the lowest common denominator is 6 as well. So we're going to have to change everything to lowest common denominator of 6, drop the denominators, and then solve for x. Let's do that. Okay, the first thing we need to do is to multiply the denominator by 3 to make 6, which means we're multiplying the numerator by 3 as well. The denominator by 2, which means we're multiplying the numerator by 2. And of course, on the right-hand side, the denominator by 6 and the numerator by 6. And we're doing this because the lowest common denominator is 6. Now that we've done that, let's put it all over one fraction. So we've got 3, 1 minus a, minus 2, 2 minus a, all over 6, which is greater than or equal to 6 over 6. How do I get rid of the two denominators? I'm going to multiply both sides by 6, and I'm going to be left with 3 minus 3a. How did I get that? I'm doing distributive law, and I'm going to do distributive law with the next bracket. Minus 2 times 2 is minus 4, and minus 2 times minus a is plus 2a. And that is greater than or equal to 6. Let's add our like terms. So we've got minus a minus 1 is greater than or equal to 6. Take the minus 1 over by adding it to both sides, and then it becomes 6 plus 1, and now, of course, do you see the problem? We have a negative a, which means we need to change it to a positive by multiplying both sides by a negative 1. What happens when we multiply both sides by a negative 1? The sign changes direction. Well done. So that means a is going to be less than or equal to negative 7. Now that we have gone over inequalities and literal equations, it's time to have a short break and get ready for our word problems. Welcome back, grade 10s. We're going to move on to word problems now. Now, with word problems, there are certain tricks that you can do to do certain ones. However, they don't always work, so you've always got to take it as it comes to you. If you see a different method to use, then use that method. The best thing you can do with word problems is practice, practice, practice. Let's move on to the first question. The first question says, 7/8 of a certain number is 5 more than a third of the number. Find the number. Now there are two ways that we can set up this equation. Firstly, we need to define what our variable is. So we're going to write let x equal a certain number. Where did I get that from? I got it directly from the question. It talks about a certain number. And also it says find the number. So that's how I know that the number must equal x. So 7/8 of a number. So that means we're going to be multiplying 7/8 by x is 5 more than 1/3 of the number. So we've got 1/3 of x plus 5 is going to be equal to 7/8 of x. Why are we adding 5 to 1/3 of x? Because 1/3 of x is 5 less than 7/8 of x. So let's go on to solving it. The first thing we're going to do is to try and get rid of these fractions. And we're going to do that by finding a lowest common denominator. In this case, our lowest common denominator is 24. And let's put everything over denominators first before we change to the lowest common denominator. So we have x over 3 plus 5 over 1. 8 needs to be multiplied by 3 to make it 24. 3 needs to be multiplied by 8 to make it 24. And 1 needs to be multiplied by 24 to make it 24. Now I'm going to need a calculator to... No, I'm not. I'm going to go straight. 7 times 3 is going to be 21x. 8 times x is 8x. Now the 5 times 24, just to check myself, I'm going to use the calculator. 5 times 24 is equals to 120. So I'm going to add 120. What kind of equation is it? It's a linear equation because x is not squared. So that means we need to isolate the variable and have all the numbers on the other side. I'm going to start by getting rid of 8x on the one side, and I do this by subtracting 8x from both sides. And now 21x minus 8x is going to give us 13x. Is equals to 120, which means that x is equals to 120 divided by 13. We can write it as a fraction or a mixed fraction if we want to. I would check your answer. You do not need to write it as a mixed fraction. And there it is, 9 3 over 13. Personally, I would just leave it as 120 over 13. And there we go. Now that's an example of a rather simple problem. The problem is with the wording. They say that a certain number is 5 more than another number. That means you take the other number and you add 5 to it to equal the certain number. You need to be careful when you're reading the question that you're understanding exactly what's being said. Let's try the next question. The next question talks about rulers and pens, and these questions are usually quite easy because people can relate to them and they can draw the pictures. So when they say 3 rulers and 2 pens, if you want to then go and draw 3 rulers and 2 pens, it's not a great pen, but we'll pretend it looks beautiful. 3 rulers plus 2 pens have a total cost of 21 Rand. If that makes you feel better, then that's what you draw. 1 ruler and 1 pen have a total cost of 8 Rand. So 1 ruler plus 1 pen has a total cost of 8 Rand. How much does a ruler cost and how much does a pen cost? Now, yes, I've drawn beautiful pictures over here, but honestly, your teacher's going to look at that and she's going to go, wrong and wrong. So how do I take my understanding of the question and turn it into maths? Let's start by saying let X be the rulers and Y be the pens. How does this help me? Well, in the first picture, I've got 3 rulers. So 3x plus, and how many pens do I have? 2 pens. 2y is equals to 21. Then I have 1 ruler plus 1 pen is equals to 8. I now have 2 equations that I need to solve, and that I'm going to do by simultaneous equations. When you're working with pictures and you're wanting, a lot of people do work with pictures with word problems, and you're wanting to turn it into maths, make sure that your pictures are consistent so that you can easily change 3 funny shaped rulers to look like 3x. Make sure that your teacher understands what you're doing, so you need to say let x equal rulers and y equal pens. These are all important skills. In this particular question, we need to do a simultaneous equation, and we're going to do it by substitution. This means we're going to label the equations and we're going to play with one so that we can fit it into another and solve for one of the variables, so on and so forth. Let's start. So we have our 2 equations over here. I'm going to start by giving them names. I'll call this one number 1 and this one number 2. Before I go any further, I need to play with one of them to make it easier to work with. So I'm going to play with the second one because it is a nicer equation to work with. I've got a single x and a single y. I need to tell the teacher that I'm working with number 2. So I write into, and I'm going to rearrange it so that it looks like x is equals to 8 minus y. And lastly, I give it a new name of number 3. Now I'm going to substitute number 3 into one of the other equations. Which one can't I substitute it into? I can't substitute it into number 2 because number 2 and number 3 are actually exactly the same, except the y is on the other side. If I were to substitute number 3 into number 2, what I'd find is I'd get an answer like 0x is equals to 0 or something. It wouldn't work out. So if you have substituted and it hasn't worked, you need to first try substituting into a different equation. Let's substitute into number 1. It means wherever there's an x, we now replace it with 8 minus y. The rest of the equation plus 2y is equals to 21. And let's solve it. Distributive law means that that is 24 minus 3y plus 2y is equals to 21. And now we have minus y on the left and 21 minus 24 on the right, which means that minus y is equals to minus 3. Multiply both sides by -1 to get that y is equals to 3. And we've solved for the price of the pens, but we haven't solved for the price of the rulers. So we know what y is going to cost. It's going to cost 3 rand. And now we need to take that 3 rand and substitute it back into one of the other equations to find the price of the other one. It doesn't actually matter which one you substitute it in. You're going to get the same answer. If you're feeling unconfident about this, then substitute it back into 2 just to make yourself feel more confident. But do this when you're practicing. Don't do it in a test. Trust yourself. By that stage, you should be familiar with the work. Let's substitute. Remember, you need to tell your teacher what you're doing. So I'm going to write subs y is equals to 3 into, and I always find it easier to substitute it into the third equation. So I'm going to write into 3. And for that equation, it was x is equals to 8 minus y, which is 3, which gives me an answer of x is equals to 5. So what does that mean? It means our pens are 3 rand and our rulers are 5 rand. Does my teacher know by this answer that I understand the work? No. My teacher knows that I can form an equation and I can then I can solve a simultaneous equation. She doesn't know that I understand that these are the prices of the objects. So I do need to indicate that I understand that. And you do that by writing a sentence. You would say, the pens cost 3 rand and the rulers cost 5 rand. And there we go. We've solved that equation. We now are going to move on to more difficult equations, but these are nice, a good warm-up for us. Let's move on. Okay. A man runs to the bus stop and back in 15 minutes. His speed on the way to the bus stop is 5 kilometers an hour, and his speed on the way back is 4 kilometers an hour. Find the distance to the bus stop. I caught the bus this morning, and when I caught the bus, I had to walk to the bus stop. Now, walking from my house to the bus stop is the same distance as when I get dropped off from the bus and walk back again. So that distance is not going to change. However, the speed I'm going to walk at is going to change. Walking there, I think it'd probably be a little faster because I'm fresh and energetic, and walking back would be a little slower. The problem is we now have an average speed of 15 minutes, or an average time of 15 minutes. We've got to then work out what the distance is to the bus stop using the information we have. We've talked about speed, we've talked about distance, and we've talked about time. So what triangle are we going to use? We're going to use the speed, distance, time triangle. And then we're going to form a table where we talk about this walk there and the walk back in terms of these 3 variables. Let's try that. Okay, the first thing I'm going to do is remind myself of what the triangle looks like. Speed is equals to distance over time, and then I'll draw a rough table for myself. Nothing too fancy, just enough to get the information in. So we're talking about the walk there and the walk back. We've got speed, the distance, and the time. The first thing we need to decide is which is x. They ask for find the distance to the bus stop. That means our distance. Let x equal the distance to the bus stop. So that means the distance is the same for both the walk there and the walk back. What else? His speed on the way to the bus stop is 5 kilometers an hour. So on the way there, he's traveling 5 kilometers an hour. And on the way back is 4 kilometers an hour. How much was his total time? Well, his total time was 15 minutes. But now we have a big gaping problem, and this is a good thing to have. We don't know what goes here yet, but we can work it out. How can we work it out? Well, time is equals to distance divided by speed. And with this method, you're always meant to have a column that you still need to work out. So in order to work out time, we've got to take our distance, which is x, and divide it by our speed. And over here, our distance, which is still x, and divide it by our speed, which is 4. Well, what this table has done for us really nicely is it has formed the equation that we have to write down. And that equation is the time it took to walk there plus the time it took to walk back is equals to 15 minutes. But wait, there's a problem. Why can't we have it in 15 minutes? The reason we can't do 15 minutes is because the other measurements were in kilometers per hour. And whatever measurement we have from the beginning, we need to stick with all the way through to the end. What's nice though is that 15 minutes fits really nicely into a fraction of an hour. If you want to change minutes to an hour, you just put the minutes over 60 to indicate that they are 15 minutes out of 60. Let's do that. So rather than writing 15, I'm going to write 15 over 60. Okay, I'm going to simplify that fraction first before looking for a common denominator. And 15 over 60 is actually 1 over 4. So what is our lowest common denominator? If you said 20, you would be correct. How do I change 5 to 20? I'm going to multiply it by 4 and multiply the top by 4. How do I change 4? I'm multiplying it by 5. Same with the other denominator of 4. So now what I have is I have 4x plus 5x over 20 is equals to 5 over 20. What can I do to the denominators? Well, I can just drop them. To show you how that's done is I am going to show you that I am multiplying both sides by 20, which then of course when you multiply fractions with fractions you can do some cancelling with top and bottom, and you now have 4x plus 5x is equals to 5, which means 9x is equals to 5, meaning that the distance to the bus stop is 5 over 9 kilometers. Let's work out what that is in real numbers. So 5 divided by 9 is equals to 0,56, we'll round it off to, which is x is equals to 0,56 kilometers. The last step would be to write it in a sentence. The distance to the bus stop is 0,56 kilometers. That is a really good example of a speed distance time problem. What you'll have is a measurement of time or distance or speed going in one direction and then coming back. Sometimes they'll talk about you traveled to Joburg in a car and traveled back on a donkey. When you went there, it took you 1 day. When you came back, it took you 7 days. What is the distance? So on and so forth. Let's go on to the next question. Okay. Zanele and Pete skate towards each other on a straight path. They set off 20 kilometers apart. Zanele skates 15 kilometers an hour and Pete 10 kilometers an hour. How far will Pete have skated when they reach each other? Now, what people want to think is that they're going to meet in the middle. But anyone who does actually do skating or running or anything knows that one person always runs slower than the other. I'm usually the slower one. So I'll be traveling this fast, whereas someone else will be that fast. And rather than meeting in the middle, as you would think, we're going to meet somewhere on this side, more towards the slower person's side. Now with these questions, they'll either ask the distance that one person has traveled or the amount of time that it takes for them to reach each other. Let's move and see how we tackle this question. Okay. Firstly, let's determine what they are looking for. How far will Pete have skated when they reach each other? So they are looking for Pete's distance. So we're going to write Pete's distance is equals to x. Let Pete's distance equal x. Now that means that Zanele's distance will be what? Well, if Pete has traveled x, then Zanele will travel 20 minus x kilometers. You'll notice that they've spoken about distance, they've spoken about speed. So what kind of problem are we doing? If you guessed speed, distance, time, you would be correct. Speed, distance, time. Except now, instead of having there and back, we've got Zanele and Pete. I'm just going to say P and Z and distance, speed, and time. We know already that Pete's distance is x and Zanele's is 20 minus x. They tell us the speeds. Zanele is at 15 kilometers an hour and Pete is at 10 kilometers an hour. Do they tell us the time? No, they don't. So that's okay, because we're always meant to work out what the last column is going to be. And how do we work out what time is? Well, look at the triangle. Time is equals to distance divided by speed. And over here, the distance is x, the speed is 10, the distance is 20 minus x, and the speed is 15. Now let's go back to that example. If I'm over here and fast person is over there, and we're both running, at what time do we reach over here? At exactly the same time. Because even though we're running at different speeds, we're still running the same amount of time. That means that Pete and Zanele's time are going to be exactly the same when they do cross into each other's paths. So for that reason, our equation will be Pete's time is equals to Zanele's time. Let's form the equation. Okay, so the equation is going to be x divided by 10 is equals to 20 minus x over 15. Once again, we have fractions, so we're going to look for a lowest common denominator, and it's going to be 30. How did I get 30? Well, 3 times 10 makes 30, and 2 times 15 makes 30. So both of them can become 30 by doing a simple multiplication problem. 3 times 10, which means we multiply the top by 3 as well, And if we're multiplying 15 by 2, we also multiply the numerator by 2 as well, leaving us with 3x is equals to 40 minus 2x. And now let's solve for x. I'm going to start by isolating the variable, bringing them all to one side, simplifying as much as I can, and then getting an answer of 40 divided by 5, which of course is 8. Now right in the beginning, we said what x was equals to. X is Pete's distance. So the last thing we have to do is write at the bottom that Pete ran, or Pete skated, 8 kilometers. When you're doing word problems, it's a good idea to think through the answer. It doesn't make sense in conjunction with the question. Now, in the question, it said that Pete was running 10 kilometers an hour and Zanele 15 kilometers an hour. So logically thinking, should Pete run more or less than Zanele? Well, obviously less. He's like me, the slower one. Everyone else is going to catch up to me. Let's move on to the next question. Question 3e. When the price of chocolates is increased by 10 Rand, we can buy 5 fewer chocolates for 300 Rand. What was the price of each chocolate before the price was increased? Okay, it's a good idea when you have a word problem to think through everything that's said. So we have 300 Rand and we want to buy some chocolates. When we bought chocolates last week, we could buy more chocolates with the 300 Rand than what we can buy this week. Now we're talking about money, we're talking about numbers of items, we're talking about the prices of items. So what kind of problem is it? It's going to be a TEN problem, a money problem. We're going to start by drawing the triangle and then tackle the problem. Just to remind us what the triangle looks like, well, firstly it points upwards, and at the top we have the T, and bottom E, and the N. Let's form the table. Remember, this is just your own calculation, so there's no reason for it to be hugely neat. I'm going to write total cost. I'm going to write price of each. And lastly, the number of chocolates. Okay. And it says when the price of chocolates is increased by 10 Rand, we can buy 5 fewer chocolates for 300. What was the price of each chocolate before the price was increased? So original price will be one of the, and new price will be the other row. They want to know the price before it was increased. So let's just write over here, let x equal the original price. And then we put it, the original price would be x. Let's look at the rest of it. When the price of chocolates is increased by 10 Rand, so what have we done to the price? We've added 10 Rand to it. We can buy 5 fewer chocolates for 300 Rand. So the total cost for each of these purchases is going to be 300. What was the price of each chocolate before the price was increased? Now it's a number of chocolates that we have to figure out over there. How do we work out number? Number is going to be equal to total divided by each. Here is our total, here is our each, and let's write that down. So 300 divided by x Let's make some more space here. 300 divided by x plus 10. There is one piece of information I haven't used yet, and that is we can buy 5 fewer chocolates for 300 Rand. So what we need to show now is that at the old price, we could buy 5 more than the new price. And that means the old number of chocolates and the new number of chocolates, which one can you buy less of? The new. So if I add 5 chocolates to the new number of chocolates, it will equal the same amount as the old number of chocolates. It does take a bit of time to get your mind around this. You've got to think of which should be less and then add to that. So for instance, if the price of the chocolates has increased and you're able to buy less chocolates, then obviously you need to add the 5 to the new price of the chocolates, or the new number of chocolates, to get the same as the old number of chocolates. Let's solve the equation. Now, the equation has fractions, and that means we're going to have to find a lowest common denominator. And this is actually the type of lowest common denominator that most people get wrong, because what they want to do is rather just add 10 to the x rather than multiplying it by x plus 10. You must make the lowest common denominator x times x plus 10. There is no way around it. Don't think you can outsmart the system. You can't. It cannot be done. Let's show it over here. We're multiplying x plus 10 to the denominator and to the numerator. And then over here, we're just multiplying by x to the denominator and the numerator, and then of course we're going to multiply the numerator and the denominator of 5 by x times x plus 10. Now in one quick step I'm going to get rid of all of the denominators and write out my new equation. 300 x plus 10 is equals to 300 x plus 5x x plus 10. Let's multiply it out and solve for x. 300x plus 3000 is equals to 300x plus 5x squared plus 50x. Let's simplify as much as we can, so that this becomes 300x plus 3000. There's not much we can do on the left hand side, but on the right hand side it does become 5x squared plus 350x. Now we can see this is a quadratic equation. Quadratic equations give us 2 answers, and there are 3 steps to doing quadratic equations. The first step is you need to make everything equal to 0. The second step is you need to factorize. Remember, there are 4 different methods to factorizing. And the last step is to divide it up into 2 parts and then solve for your variable. So let's start by making everything equal to 0. Okay. I'm going to keep 5x squared where it's positive, and I have 350x in the same place, and I'm taking away 300x. How did that happen? Well, in order to move 300x from the left, I've got to actually subtract it from both sides. The same thing with the 3000. And now let's add our like terms. 5x squared stays the same, but now we have 50x and minus 3000. Now you'll remember that we always look for a common factor first. And what's a common factor here? It's going to be 5. So let's take out 5 as a common factor. X squared plus 10x. And just to make sure we get that right, let's do it on a calculator. 3000 divided by 5 is going to be 600. 600 is far easier to work with than 3,000. And remember, we can do a little trick here and divide both sides by 5, meaning that we get 0 is equals to x squared plus 10x minus 600. We're now going to do trinomial calculations. I'll do it very small on the side to find out what our brackets are going to be. Well, x is easy. X squared just becomes x and x. What does minus 600 become? Well, 60 times 10 can give us 600. Will 50 work? 600 divided by 50 gives us 10. That doesn't sound right. 600 divided by 50 gives us 12. So 50 times by 12 gives us 600, but that's not going to work because we need 10. So let's try again. How about 25? 600 divided by 25. 24 times 25. Will that work? No, because we need 10. So why don't we try 20? 600 divided by 20 gives us 30. Now that's going to work really nicely because 20 and 30, the difference between them is 10. Let's make some more space. 20 times by 30 gives us 600. And we need our middle term to be plus 10x. So when we write down the 20 and the 30, which one's going to be negative? It's going to be the negative 20. Negative 20 times x is negative 20x. X times 30 is 30x. When we add those two together, we get the middle term, which is what we want. Let's write down our brackets. 0 is equals to x minus 20 and x plus 30. And that means that x will be equal to either 20 or x will be equal to negative 30. You'll remember a few moments ago we spoke about thinking about things logically. Now you're thinking about the price of chocolates. Is it possible for a chocolate to cost minus 30 Rand? Well, I wish so, because then someone would pay you for eating it. But no, if you're going to a shop, you're going to pay money to eat it. This means that the original price of the chocolate was 20 Rand. So let's write that down. The original price of the chocolate is 20 Rand. And with that, I think it's time for a break. You need to go and relax and shake a leg, feel good, and we'll see you just now. Welcome back, grade 10s. We're going to carry on with some word problems. Let's see what we've got next. Two jets are flying towards each other from airports that are 1,200 kilometers apart. The one jet is flying at 200 kilometers per hour and the other jet at 350 kilometers per hour. If they took off at the same time, how long will it take for the jets to pass each other? Okay, sometimes it helps to draw a little picture. So here we have airport A and airport B. We've got one jet that's flying this way and the other jet that's flying that way. This jet is traveling 250 kilometers an hour and this one is traveling 350 kilometers per hour. So this jet B is actually traveling faster than jet A, or from airport A. The distance between the two airports is 1,200 kilometers from each other. Now, when these two jets meet at this point or pass each other at this point, their combined distance is going to be 1,200 kilometers. You'll notice that we've used some key terminology here. We've used speed, we've used distance, and we've used time, which should give you a clue that that triangle is going to help here. So let's set up our table and decide what our x is going to be, form the equation, and solve for x. Okay, the first thing I'm going to do is remind us what the triangle looks like. There it is, and speed is equals to distance divided by time. Next, let's draw the table, and there it is. And we need to, if they took off at the same time, how long will it take for the jets to pass each other? What's going to be our x? Let time equal x. Now they're going to take the same amount of time to travel until the point that they pass each other. We're going to call the one plane, plane A, and the other plane, plane B. The distance is going to be something else. We do know the speed. And the speed of plane A is 250 kilometers per hour, and of B is 350 kilometers per hour. Now don't let that sense of panic settle. You need to find out what the distance is, and this is normal. You need to establish it by using the triangle. Distance is equals to speed times time, and we know this from the triangle. So distance equals speed times time. The speed is 250 kilometers, the time is x. The speed is 350 kilometers, the time is x. Let's make sure we've used all of the information. Two jets are flying towards each other from airports that are 1,200 kilometers apart. One jet is flying 250 kilometers an hour, the other jet at 350 kilometers an hour. If they took off at the same time, how long would it take for the jets to pass each other? The only information we haven't used is the 1,250 kilometers. Now we know that when they reach each other, they are going to have flown a combined distance of 1,250 kilometers. That means our equation is going to be plane A's distance plus plane B's distance equals 1,250 kilometers. Now it's pretty plain sailing. 250x plus 350x gives us 600x is equals to 1,200. Now to solve for x, we just need to divide. Can you see how we're flying through this problem? It's great. 1,200 divided by 600 gives us x is equals to 2. What was x meant to be? It was meant to be the time, and all of our time measurements are in hours. That means the planes will reach each other at 2 hours. Will reach each other after flying for 2 hours. Now, they were not asking for that as the answer. They were asking, how long will it take for the jets to pass each other? So you need to say that then they will pass each other. The planes will reach each other after flying for 2 hours, and then they will pass each other. Okay. Well, there we go. Well, that was pretty easy. let's move on to the next question. Question 4. Kadesh bought 20 shirts at a total cost of 980 Rand. If the large shirts cost 50 Rand and the small shirts cost 40 Rand, how many of each size did he buy? So far we've talked about the number of shirts, we've talked about small and large, so they're two different types. We've talked about the total cost as well as the cost of each. So let's see if we can put this into the table. We're going to use the TEN triangle and put it in the table. So at the top we have the T, then the E and the N, and our table has 3 columns, well 4 if you include the one on the side. Very skew line. Let's redraw that. There we go. And we've got total, we've got each, and number. Then we've got small, and we've got large. Let's fill in what we know. Kadesh bought 20 t-shirts. So how many in total did he buy? The total number of shirts he bought was 20 at a total cost of 980 Rand. So the total cost of all of them would be 980 Rand. If the large shirts cost 50 Rand and the small shirts cost 40, so price of each, large cost 50 and the small cost 40, how many of each side did he buy? Well, they haven't given us a number, specific value that they want. They've told us to find out how many large and small he's bought. So we can choose. Do we want large to be X or small to be X? I'm going to choose large to be X. Let's write that down. Let the number of large shirts equal X. Now, if the number of large shirts equals X, that means the number of small shirts will be what? And if you said 20 minus X, I am very proud of you. There we go. 20 minus X. How do I know that? Because the total number of shirts bought are 20. So 20 minus X plus X will give me a total of 20. Remember that we are still meant to have a column missing, and here is where that column is. We still need to fill in those values. How do we find them? Well, total is equals to each times number. And that means in that column, we're going to multiply each by number. So each by number and each by number. And what they've said is that the total price is going to be 980. That's really nice then, because our equation has been established for us. All we need to then write down is that 40 times by 20 minus X plus 50 times by X is equals to 980. So the total price of the small shirts plus the total price of the large shirts is equals to a total price of 980 Rand. Let's multiply it out. 800, because 40 times 20 is 800, minus 40x plus 50x, whoopsie, plus 50x is equals to 980. Minus 40x plus 50x leaves me with 10x, and I'm going to move the 800 over by subtracting 800 from both sides. So 980 minus 800, and that means that 10x is equals to 180. which means that x is equals to 180 divided by 10, which is 18. What was x equals to? X was the number of large shirts, so that means 18 large shirts were bought and 2 small shirts, as well as 2 small shirts. We've answered the question. It sounds like a logical answer. Everything's going well. Let's move on to the next question. Now the next question I like quite a bit because it's a different type of skill and you don't see these types of questions very often. Let's go through it. The diagonal of a rectangle is 25 centimeters more than its width. The length of the rectangle is 17 centimeters more than its width. What are the dimensions of the rectangle? Well, firstly, it's asked for the dimensions of the rectangle, so it hasn't given you a clear indication of what it wants to be x. So I'm going to use the width as x. I'm going to start by drawing my rectangle and write on the side, let width equal x, and then I'm going to put it in. What do we know about a rectangle? We know that it's got right angles all the way around, that the opposite sides are equal to each other, and that the diagonals bisect each other. Now I'm just going to put those measurements in, or those lines in. So I have a width. The next piece of information, the diagonal of a rectangle is 25 centimeters more. So the diagonal is going to be x plus 25. The length of the rectangle is 17 centimeters more than the width. And there we go. Now if you look at this, it looks like a very mixed up picture. However, you look a little closer and you have got all the measurements for a right angled triangle. And at this point you must be thinking Pythagoras. Remember, Pythagoras is when the hypotenuse squared is equals to the sum of the other two sides squared. Let's apply this rule to this picture. Okay. Firstly, tell your teacher what you're doing. So write Pythagoras down somewhere. And then let's highlight which ones are sides. This is a side, this is a side, that is the hypotenuse. Just to make it easier to see, so the hypotenuse squared is equals to the sum of the other two sides squared. Let's multiply it out, and I'm going to do that by doing FOIL. So that means I'm going to rewrite all of the brackets and then do FOIL in the next step. Well, x squared can become x squared, and then we're left with x plus 17 and x plus 17. Okay, x times x is x squared, x times 25 is 25x, 25 times x is 25x, and 25 times 25 should be 625, but let's check it just in case. And there we go, 625. It's always a good idea to check yourself if you're not certain. And even if you are certain, to check your work. Okay, x times x is x squared, x times 17 is 17x, 17 times x is 17x, and lastly 17 times 17, let's check it, 17 times 17 is equals to 289. I'm going to put it down here, plus 289. Okay, let's add what we can on either side. We have x squared plus 50x plus 625. is equals to 2x squared plus 34x plus 289. Now, because it's a quadratic equation, let's make everything equal to 0. So we have 2x squared minus x squared plus 34x minus 50x plus 289 minus 625, and that's 0 is equals to x squared minus, and let's just check this on the calculator, minus 50 plus 34 is equals to minus 16. So minus 16x, and the last one, it is 289. 289 minus 625 is equals to minus 336. Okay. A quadratic equation calls for us to factorize. There's no common factor, there's no difference of two squares, so we're going to have to do a trinomial. We can look at it and see already that there are factors that are popping out to us. Let's see what happens. Okay. We'll start by establishing the shape of it, and we've got x times x gives us x squared. I'm going to fiddle with the calculator a little. We need two numbers that are quite close together. So 336 divided by 12 is going to give us 28. So 12 times 28, 12 times 28 gives us 336. Now I know it is a negative, and we are going to put a negative in just now, once we've established which one should be negative. X times 28 gives us 28x, and x times 12 gives us 12x. 12x and 28x, is there any way we can turn that into negative 16? Yes, if the 28 is negative. So that means our factors are x plus 12 and x minus 28. The last step is to solve for x by dividing up the factors. And what we have is x is equals to negative 12 and x is equals to 28. Is it possible to have a negative distance or a negative length measurement? No, it's not. It's possible to have negative money. Yes, you can be in debt, but it's not possible to have a negative distance. So we are going to take the positive distance as the answer and write it in the final sentence. We're going to write the width is 28 centimeters. The length is, well, the length was x plus 17, so 28 plus 17 is 45. The length is 45 centimeters, and the diagonal is x plus 25, which means it's going to be 43. Let's just check that. 28 plus 25 is not 43, it's 53. Good thing we check it. Is 53 centimeters. You've experienced a wide range of word problems now, and you've got the skills to try them by yourselves. You need to practice to get this right. Do what you can, and you will do great. Enjoy the rest of your day, grade 10s.